I'm Sheena Larson, and this is one of my clinical mentors, Dr. Licks. This is her dog, Kaya. I'm just going to be talking about how to do an ECG, an electrocardiogram. So I have my ECG monitor there, and I have some alcohol. And one second, I just noticed that my clips are falling apart. So we have Kaya here in right lateral recumbency, and we're going to be attaching the leads. How I remember the colors are Christmas trees, or newspapers over Christmas trees, and grass and snow on the ground. So that means that we're going to take the white lead. Oh. We want to attach, sorry baby, we want to attach the leads just proximal to the elbows, and then just proximal to the stifles. And I'm just applying some alcohol to the area that I'm going to be attaching the leads. Sorry, it's just a little bit cold. So she's in right lateral recumbency, so I'm just going to take the white lead and I'm going to attach that to her right forelimb. And then I'm going to take the black lead and I'm going to attach that to her left forelimb. And I'm making sure that it's actually contacting the skin, not just catching hair. So it's pinching a little bit, sorry. And then green goes on the right hind leg, and red just goes onto the left hind leg. And then I have my monitor here, and you can see that we're getting the reading. So on a normal ECG machine, there are the 3 different leads, or 6 different leads, 1 to 3, and then AVR, AVL, and AVF. And we would take a reading, 5 to 6 readings for each lead, 1 to 3, and then the others, and then, but lead 2 is the one most common. Leads 1 to 3 are bipolar, AVR, AVL, and AVF are unipolar, so they get information from one limb. This one here is calculating the heart rate. And then for us, if we are having troubles, we're wanting to make sure that she's on a non-conductive surface. We want to make sure that none of the leads are touching each other. We want to make sure that she's staying as stationary as possible, because you can get a movement artifact like that there. And how we don't want her to be under anesthetic if we're taking an actual ECG, because a lot of drugs can affect cardiac output. So we want to make sure that we are getting an accurate result. And then you can see here how Kaya's getting used to what we're doing, and her heart rate is getting to be a little bit slower. So I do believe that that is everything. On an actual ECG machine, we would have a printed output, but ours is unable to do so.